Stephanie. So I'm really happy to be here with you all today, and we're going to talk today, of course, about images and doing figures in your writing. So I'm with the departments, I'm a research faculty member in the departments of biochemistry and biology, and I also direct the electron microscopy core lab. So some of the images you'll see here are from the electron microscope. So beware. All right, so let's start off. I want to start off. I did a presentation last summer about writing and in science, and I used this quote right at the beginning because a teacher of mine that I had in a scientific writing class a long time ago used this same quote, the part in blue. And this is a letter from Charles Darwin to his colleague Lyell in 1867, where he kind of laments the fact that writing is kind of hard. And so it is tough. It's hard. It's hard even if you've written for many years. I was trying to advise my daughter, who's a freshman here at the university last night, about her work. She was having writer's block. It's normal, and it's okay, and you're normal if you have the writer's block. Even Charles Darwin did. And notice this is 1867, so his book, his first book on Origin of Species was written at least 8 years earlier. So he'd been writing for many years. So if he can have a hard time with it, you can too and feel okay, right? So, but it's very fulfilling and it will help you learn. I think I learn more writing than in almost any other activity. So today, this is the outline, what we're going to do. So we're going to talk about the purpose of illustrations, the types of illustrations that you can have, how to prepare figures, a few tips on that. We're going to talk about the figure caption. We're going to talk about citing figures within the text, and then I'm going to end with some stuff about integrity. Okay, so let's get started. Why do we use illustrations? And I want this to be interactive. So tell me why do we use illustrations and I'm going to write some responses up here on the board. Why use illustrations? Yeah.
It's a bit easier than writing. A picture's worth 1,000 words.
Okay, very good. So a picture is worth equals 1,000 words. Okay? Very good. Very good idea. In many cases it is. It's maybe the best way. So in some cases it's the best way to convey information. Okay? Okay, we should say in some cases. And we'll talk more about this in a minute. Anybody else have any other thoughts? Okay. Easy to understand. Okay? These are good answers. All right? So, what I want you to think about, though, and always remember, is that it is a form of writing. So this is Newspaper Rock State Park, just south of Moab, several miles. And if you go there, you see all this stuff on here. The people who have researched this still don't understand what's going on here. We don't really know what the people were trying to say. But this is a form of writing, right? We look at cave paintings or art like this, and we realize that they're trying to communicate something, right? So it is a form of communication. It's a form of writing, and you should think of it like that. But as I said a few minutes ago about being hard, this can be hard too. Making a figure, yes, it's easy to understand. It's worth 1,000 words, but it can still be difficult to do it right and to do it well. So don't be surprised if it takes me probably at least a day for every figure that I do. Probably. Maybe in many cases longer than a day. Okay, so what medium, one of the things you have to decide as a writer, as you're writing something, is what's the best form to convey information? Is it an illustration? Is it words? Is it a table? Is it an equation? So you have to decide what's the best way and the best form to convey that information. And a figure may not always be the best way. Okay? And also you can remember, okay, so, yeah, so, wait, let's go back here and let's talk about, let's maybe talk a little bit about how, what would make, I don't know, what would make a figure a good way to convey information? What makes a figure a good, what information is good to convey in a figure?
Information collected visually.
Okay, all right, so let's erase this. Okay, a figure. So some visual information. So it's a lot easier if I want to put a picture of someone, if I want to have a picture of one of you, if I want to say this is what you look like, it would be a lot easier to show a picture than it would be to try to describe, right? Okay, okay, all right. Okay, so we've got figures, words, table, and equation. Okay, so any of these, what can be a good way to, what kind of data or what kind of information is good in any of these cases? Think of anything?
Data or figures.
Sorry?
Big data or figures, maybe.
Sorry, I missed what you're saying.
Big data.
Big data?
Probably.
What do you mean like big by big?
If it's huge amount of data, probably it's easy to just show a figure instead of explaining by rules or equations.
Okay, okay. Yeah, so if it maybe large amounts of data. Okay, but these could also maybe be appropriate for here as well. So what about a table? When is maybe a table appropriate? Sorry?
Organized data.
Okay, you want to organize, all right? Organized, especially if you have lots of numerical data, like precise numbers. Tables are often good for precise numbers. Comparisons, yeah, maybe comparisons. But the comparison, you might have a comparison that would be good here. If you have a visual comparison, if you want to make a visual comparison, you can use figures. And remember, you can also use a table of figures. Especially if you're doing lots of comparisons, you might use a table of figures. So you can combine some of these. Okay? So think about as you're writing what form might be best. An equation is good when you need a precise definition often. Okay? Okay, you've probably learned this one, F equals ma. That's a very precise definition, isn't it? So equations. So you do have to think about what's appropriate and what's the best way to convey the information that you want. So, as I said, you can combine a table of figures or a figure with equations in it. And you may often need to just draft it. You may need to, yeah, it takes a lot of work, but just draft it. Make a table, make a figure. See what looks best. And you probably will have to do that. And be willing to throw things out. That's one of the hardest things about writing, is throwing something out, because you put a lot of work in that, and throwing it out is no fun. So maybe a thought, this is what I like to do, is when I'm writing something and I've spent a lot of work on this, I really like what I wrote. You know, that's great. It's really great, but it's got to go. So I have a little separate document, or I put it at the end of the document, kind of a place where I can put stuff. So I still have it, I still haven't, you know, if I want to go back to it, if I figure out a way to I need it, I have it there. But like I put notes, like I have notes. So that's one way you can at least throw stuff away easier, at least I've found. Okay, all right, let's talk about types of illustration, and let's talk about what type of information is conveyed this way. And so which form, and so you have to decide this as a writer, which form conveys information in the best way for the message that you're trying to send. Okay, so let's talk about graphs. Let's talk about these three. So I am going to make a table. So I think the most appropriate way to do this is to actually make a table. So we're going to come over here to the board again, and I'm going to make a table of the different types of illustrations. Okay, so we're going to have type, and we'll have a little. We may need to define it if we, in some cases we may need to do that. Then we're going to have what information is conveyed. Okay, so if we have a line graph, okay, so a line graph is usually something like this, where you have an x-axis and a y-axis, and you have some kind of a line, a relationship between the x and the y-axis. So this shows trends. So if you want to show a trend over, you know, a trend of something over time, for example, or length or something, then a line graph is appropriate. Okay, a bar graph is good to show magnitudes. Okay, so magnitudes of different things. And then another one is a pie chart, the pie chart. And this shows parts of a whole. Okay, you want to show the whole thing and how it's divided into parts. Another form is a map. A map is good for showing location information. Another one is a drawing of some kind. And this is good for descriptions, especially simplified descriptions. Okay, they're usually simplified in some way. Okay, so let me show you, now let me go back up to the front here, and let's show a couple of other examples of other types. Okay, so there's chemical structures. We have chemical schemes. So that particular chemical structure up there, if we want it, this is retinal, the chemical retinal, and if we want to show its photoisomerization, here's a diagram, a simplified scheme of it. And here's another form of kind of the same idea. This is a flow chart. Okay, so let's talk about those up. Let's write up here. So what do they show? Okay, what kind of information do you see in these? So these are all, in fact, schemes, chemical structures. Chemical structure, a scheme. and a flow chart. All of these types we could basically define as some kind of a line drawing or line art. Line drawing or art. Okay, so a chemical structure is again a description. And so it's basically a type of a drawing. So does it represent the real structure? Those of you who are chemists? No, it's a representation, right? It's a representation. But it's not... Anyway, in one sense that's what it looks like, but in another sense it doesn't, right? And you always have to keep that in mind. So a scheme which would show relationships, and connections, and processes. Okay, so a flow chart, same, basically the same. Okay, so flow charts and schemes are kind of the same idea. All right, so this diagram here, this was made by a student for a review paper, for a paper she wrote on processing of nuclear fuel, and this was part of her paper showing how the different ways that nuclear fuel can be handled. Okay, any thoughts on any of these types? So this one has a lot of words in it, and that's perfectly fine. That may be what's appropriate. Here's one that shows, has more drawings in it. Okay, but again, words, because they're kind of needed, at least in this one. So, okay, here's a photograph. I put in quotes. This is from an electron microscope. This is poliovirus. So this is another type of photograph. So let's go back over here. So we have three more types I want to talk about. So this we in the electron microscopy world, we more precisely call this a micrograph because it's actually formed not by light but by electrons. Actually made that image, but it's a photograph in the same sense. Okay, so photographs can show details, can show context. And it can be personal, and it can be a personalizing thing, a way to personalize things. So you may write a paper and you want to show, Einstein, or for some reason, or or whoever was the person involved in the study. So that's a nice way you can use it to personalize it. So two more that are related to this, and I'll show you examples up there, is one's called the stereo pair. And this is good for three-dimensional views. This will show 3D relationships. And then the last one is one that you're pretty familiar with in this day and age with movies. This didn't used to be so common because it's really hard to do it in print. Right? It's really hard to make a movie in a magazine, printed magazine. But they're more and more common now. So this is good for showing time-dependent details. Comparisons, and it's also good for showing 3 dimensions. Okay, now what a lot of journals do, although it's you still can't put it in a 2-dimensional printed thing, but you put it is a supplement, and you can download a movie, and you can look at a movie. So many papers that I'm involved with will include a movie as part of the supplemental information that you can download and look at on your computer. Okay? And these are often more kind of photographic type images. But they could be drawings as well. They could be drawings. You know, you can have an animation is appropriate. So there's a Janet Iwasa in the biochemistry department is really good at this. She's done a lot of animations that are really effective in helping us understand certain processes. So you can make a movie that's basically a flow chart that's showing some process. So she can show how, you know, certain proteins are binding together in a virus infection, for example. Okay, any questions? Okay, so here's a stereo pair. This is poliovirus with an antibody bound, and the right view, the structure, this is a three-dimensional structure, a view of a three-dimensional structure. The right view is a few degrees different from the one on the left. And when your eyes look at that, some of you may be able to do this, but if you can diverge your eyes so that just your right eye sees this and just your left eye sees that, you'll see that in stereo. And I have this up here at the end. If you'd like to come up here at the end and look at some examples of some stereo drawings, you can use these glasses and just adjust them back and forth like this, or just stare at it without using these stereo glasses. And there's a couple of some examples up here you can have a look at to see. But if any of you have seen the Magic Eye books, the same idea. The idea is you have to diverge your eyes, get your right eye to see one thing, your left eye to see a slightly different view, and then your brain will synthesize it into a stereo picture. So this can be very effective in representing three dimensions. Okay. All right, so here's one way you can look at things is you can just print the frames in 2D and in papers, and people have done this, okay? But look at these two things. These are two views. These are actually two different forms of hepatitis B virus, the capsid. This is the protein shell that's around hepatitis B virus. They're slightly different. Can you see the difference there? Okay? It's a little hard to see. And if I told you what to look for, you might be able to see it. Okay? But it's a little bit hard. Now look at this movie. This is a movie showing those two frames, just flashing those two frames back and forth. Isn't that a lot easier to see? You can see it's very subtle the very subtle difference. Okay, look right here if you haven't seen it yet. So this up, and then goes up, and then down. Okay, just a very slight change, and these are the kinds of things that we look for when we study protein structure. We sometimes look at very subtle differences, and this can actually be very important for how viruses and other cellular things work. Okay? So this movie is more effective than just having those two frames side by side. So, I mean, but maybe one way, though, that if it was difficult to do a movie and I really needed to do that, is I could probably put some highlights here to show the differences here in this relationship. Now you can probably see it, right? You can probably see a little bit of the differences now that you've seen that movie. But again, the movie is very effective. Okay, so what about this? This is a poliovirus three-dimensional structure. And see how the rotation of it helps you see that in 3 dimensions now, right? It helps you kind of get the three-dimensional feel of it a little better than when it's just just a still picture. Okay, so, all right, so movies can be effective. All right, preparing figures, let's talk about that. So, here's some my suggestions for how to prepare figures for your papers you do in classes, or papers you're going to do for publication, or papers on your posters that you're going to do for your research, right? Prepare it at the size it's going to appear. So one of the things that's really surprising sometimes is to make a graph. You think it looks great, a line graph, for example. You think it looks great on your computer, but then you print it and it's really small. It looks awful. And so make sure that you prepare the figure at the size it's going to appear, because otherwise you may it may not look very good, and it may not convey the information very effectively. Don't make the lines too thin, at least bigger than half a point. No smaller than that. What I've often found is that you have to exaggerate, especially in line graphs. Exaggerate, make it thicker, much thicker than you think it needs to be. And it'll look a little bit funny on the computer, but when it's printed out and so forth, it'll look much better. Okay, don't make the lines too thin. And keep it as simple as possible. I'll show you an example of that in a minute. Okay, simple. Label your axes clearly, and make sure you include units, magnitudes of those units. And use color only when it serves a purpose. Okay. So I guess maybe an example of making sure you use units and so forth. You know, if I just put this graph here and said this is the tuition cost, if I titled this as tuition costs, I mean, okay, you don't really have a context, right? This could have been a long time ago, and you just got to, you got a label here, year, 1950, 1980, 2000, whatever. Okay, you've got to label it, and that's what I mean. Some of this is kind of obvious, but it's amazing how often it gets neglected. All right. Okay, so here's a three-dimensional plot. Okay, it looks kind of cool. You can get all kinds of graphics programs that can do really cool stuff, like make a 3D plot like this. Okay, this is a little hard to see. It's a little pixelated. But what this says, it says Latin America, Asia Pacific, European Union, United States. This is showing some trend. But is this three-dimensional plot necessary? Did they need to do it this way? No. They could have just made it just as nice and simplified it by just making it a two-dimensional plot, okay, and then just labeled every line, right? This could have been much better, much easier to read than if it would have just been a two-dimensional plot. Okay, so make sure you simplify things. Do it the simplest way possible. Okay, here's a paper with a nice blue line in it. So, in this day and age, it's really nice to have color and stuff, and it makes it look nice. But is that blue really helpful? It's not that helpful, is it? Okay. Now, if I had 10 lines in here, 10 different plots, okay, 10 different curves in here, then yeah, it would be helpful. But it's not really necessary here. All right, what about this one? This is one I did, actually. What do you think? What do you guys think? Does color enhance the one on the left? Which one looks better to you?
The color.
The color, why?
Because it's more detail and I can kind of see in between the wedges and all that.
Okay. Anybody else? Any other thoughts? Everybody agree with him? Yeah.
I agree with him. It gives you an idea of the in-between elevations
Uh-huh.
right?
Right. It gives a sense of depth more, right? Probably, right? Yeah. So I would say that color is helpful here because it's helping you see some depth. It's seeing, and it actually looks a little nicer on my computer. But yeah, I mean, there's a reason for it. Use it if it's helpful. But what I'm saying is, don't just make things flashy and pretty just because you want to make it in color. Okay, just do what's helpful to convey the information. Okay, let's talk about figure captions. All right, think of the caption as part of the image. You're not done until the caption's done. You might have the most beautiful picture, but if you can't explain what it's there for, you're not done. So make sure that you remember to put the caption together, and spend time on it. Okay, this is that you should. It's part of it, and make it good. So this is basically the form. You'll say figure X, whatever the number 1, 2, whatever. Usually it's an Arabic number, but it may be different depending on the style preferred by the journal or by your teacher. Then you usually have a title. Then you have a title, and it's usually not a sentence. So the title is just a title your figure, okay, of something. Give it a title, and then you have sentence descriptions. So those are the parts. It's parts of the caption. Any questions on that? Yes.
I don't know if you're going to cover this, but how redundant should it be with how you're prefacing the figure in your words?
Oh, good. So how in your text, the main text?
Yes.
Okay, that's a very good point. So I would say I'm going to talk about that in just a minute about referencing it in the text. So, let's say it. I'll say it twice. Okay. So the idea is, in the text, you want to give an overall message about the figure. What do you want as a reader, as you're reading the text? What do you want the reader to know about the figure? What is the main message you want the reader to get out of that figure that's coming up? And then you refer to the figure and let them go to the figure and see all kinds of details. So the caption is the place for detail. This is the place for a lot of detail, not in your main text. This is where you want to put the detail that's describing the figure, not in the text. In the text, you just want basically an overall message.
Maybe they both say the result, key result.
They could, in a sense, yes. Let me see if I can, at the end, let's think about more, and I'm going to try to show you what I mean exactly. Okay? Give you an example of that. That's a really good question. All right, here's some other steps. But in the caption, make it understandable. We want the figure to be understandable without reference to anything else. So a reader could pull up the picture. Okay, so here's an example. Okay, I've got one of the examples I've got up here. So a reader sees this and should be able to go to this figure caption and understand what's in the figure. Now, they may not get all the implications of why this is important. That can be in your paper. But the reader should be able to understand what is in the figure. So that maybe gets to your question. Make sure that the reader can understand what's in the figure just by reading the figure caption. They don't need to go. They shouldn't have to go anywhere else. They shouldn't have to go anywhere else in the paper. Although you should, you should cite references. If you're, for example, if this picture C right here came from a paper from 2010, reference it. You should reference it. But what I mean is, the reader should be able to understand what's in this figure without going to that paper or going anywhere else in the paper. The reader should know that these are round circular particles that were isolated in Panama, okay, or something like that. These are round circular viruses that were isolated in Panama. The reader should know that, not have to go anywhere else in the paper. Does that make sense? Make sense? Okay. You shouldn't say like see figure 2 or see figure 10, whatever, to figure that out. Or see the main text or see the methods. Don't do that. Just to have it be clear. And then if there's any reason to have a credit line, you can put that at the end of the caption. If you're not citing something, but maybe you got the image was from so and so's lab. You want to just acknowledge them. You could do that at the end of the caption. Okay, so citing figures within the text. This gets to his question. So the figures they're numbered sequentially. So figure 1 will be the first figure if you are reading the text. So as I'm reading this paper, if I come to the very first, so here it says figure 2A. And then it says figure 2B, and then down here it says figure 3. So as a person reads, as your reader reads the text, the very first figure is the first one that they get to in the text. So if you want people to see figure 1, if you wanted them to see this figure before they see this figure, then this one is numbered ahead of this one. Does that make sense? Okay? And every figure should be cited within the text. Don't put figures in there if they're not cited within the text. There should be, and you should refer to the figure informatively, followed by a parenthetical reference to the figure. Okay, I'm going to give you an example of that. And so, what message do you want the reader to get from this figure, from your figure? Okay, so I'll give you an example here, and then I'll come back and let you write this down in your notes. Okay, so here's an example. So you'll often see people do this. Figure X shows the steps of translation in the ribosome. Okay, that's telling them what they can find there. That if you go to figure X, you'll see that there's steps. Okay, but this is more informative. Translation involves 10 steps. So this is more informative, right? This is a message. I want the reader to go. My paper is a review of translation. Translation of in proteins to make. It's how proteins are made, right? So I want the reader to go to my figure X, and I want them to be able to see that there's 10 steps involved. And there they'll get the detail about the 10 steps. The step 1 does this, and 2, and so forth. But I want them to know that it's an involved process. It's a detailed process. Okay, so that's one example. Okay, so all right. Any questions on this? So try to think of a simple, a straightforward message that the reader can get from your figure, and just say, I want this translation involves 10 steps. Figure C and figure X will show you those 10 steps. So it's something that they can expect. A reader could expect that if I go to figure X, I'm going to learn about 10 steps. Okay? Yeah.
So I just am wondering, if you took your own image, how do you don't cite that, right? You just put it in there with your caption, and then you're good.
That's right, because you are going to become the citation for that figure. Right. Yes, that's your original data. You don't cite your original. No, right? Yeah, yeah. That's good. That's good. Okay. Okay. Are we ready to move on? Anything else? Okay, so let's talk about integrity. In school, I'm sure you've all had. Of course, you understand the pressure of getting things in on time and and wanting to do a good job. But there's, of course, the temptation to plagiarize and cheat in different ways. So I would urge you all to decide today, or if you haven't already, or if you maybe plagiarized or been unethical in the past, to decide to not do that again. I'm going to give you some examples with imaging that anyway, I'll give you some examples, but I hope you will decide today that you're going to be ethical and won't plagiarize, and that you'll decide you're not going to distort data, you're not going to fake results. People have, of course, and it's not good. And you'll get caught. So here's a couple of examples. All right, this is from Ithaca Times in 2000, the year 2000. So the top, this is the front page of this, I think it's a newspaper. So you're college students. I'm sure that you aren't so happy when the university says that we're raising tuition again. And so how would you feel if you came across this that showed university tuition going up and your ranking of your university going down? This happens to be Cornell. Okay? It looks like it's going down. Wow. You're paying more for less bang, right? Okay, well, all right, so this is a little bit of a bad scan image. This is the best I could find, but you know, I'm sure you can all sympathize with this. But okay, what's wrong with this illustration? Now look at it. We've got the numbers in there a little more clearly. It's tuition and ranking. Okay, what's wrong with this illustration?
The years don't match up.
Yes, the years don't match up, do they? Okay, but they've made them appear that they do, because the message, they're angry, they're upset about the college tuition increases. Okay, so here's the real graphs here on the right. So between 1965 and 2000, yes, the tuition has gone as an increasingly large share of the median student family income. But over only 12 years, from 1988 to 1999, Cornell's ranking in the U.S. News and World Report has really kind of erratic. It's not really that much different. It's gone up to 14. It's down to, well, actually, look, rank is 6. So actually, it's gotten better. Okay? All right? So a little deceiving, aren't they? Okay? Okay, so let me show you an example that happened here that I became aware of. So this was an image taken on one of our microscopes. I told you I run the electron microscope lab. That appeared in a journal, Nanoletters journal, a few years ago. And an astute reviewer happened to notice, and watch what happens when I make this a little bigger. All right, can you notice anything about these? Okay. Let's see if we move it around a little bit. Okay. So I was made aware of this, and I actually looked through some of the old data we still had. And let me show you what the original image really looked like. Okay, this was the original image. So, so in the electron microscope, so I mean, look at this. Every detail, see this? That's exactly the same as it is here, is right here. This little blotch is the same. It's there. Look at this little feature. It's the same right there. I mean, everything was the same, and there were several images like that were doctored like this. So this turns out there was a big investigation. The professor was probably almost lost his job. Well, he did almost lose his job, I'm sure. But it was turned out that I guess just the graduate student was the one that was all responsible for this, and the professor wasn't really aware. But anyway, the graduate student ended up losing his PhD, and fortunately, this was caught before it was published. Some people kind of laughed at the idea that, well, the person really did a stupid Photoshop job. But I guess I would say that that's not the real problem. The problem wasn't that he didn't use Photoshop very well. The problem was that he tried to fudge data. Okay, don't do it. Don't do it. You'll get caught. If it's important, somebody's going to repeat it. Somebody will find out. It's not worth it. It's not worth it. Don't. It's just not worth it. So I hope that you will, just remember that. We're all tempted to want to do well and get famous and get a lot of credit but it's not worth this. It's not worth this kind of baloney. So okay. So that's all that I have. Is there any questions? Any other questions? I'll try to see if I can get into more of the question that I don't know your name, but that you asked. Let's see if I can find an example. So thank you all for your attention, and it's been great to be with you. And if those of you would like to stick around, I'm going to look for an example to illustrate what I was mentioning. Thank you.